Before going to the identification of chains, we should know about the elements of chains. So combination of links makes the chain. So link is defined as a rigid body which have at least two nodes. It is used for the attachment with the other links. When the link has two connection points, we call it as a binary link, and link with three connection points, we call it as a ternary link, and link with four connection points or four nodes, we call it as a quaternary link. So the characteristics of links are: link need not be a rigid body, but it should be a resistant body that is capable of transmitting the forces without negligible deformation, and it should have relative motion between each other. In the link with two connection points, we call it as a simple link, and link with more than two connection points, we call it as a complex link. In this figure, the link with number 2 and number 6 we has three connection points, so we call it as a complex link. All other links are simple links. So the linkages are made up of links and joints. These linkages forms the basic building block for the functioning of the mechanism. So basic example for the mechanisms are cam pairs, gears and gear drives, belt and belt drives, and chain and sprocket wheel. These form the basic linkages. Coming to the pairs, a joint is a connection between two or more links which has some relative motion between the connected links. So in this picture, you have the 4-bar mechanism where one link is fixed, the crank is rotated, and this rotary motion of the crank is converted into the oscillatory motion of the follower. So joint with two links at a point is called binary joint, and 3 links at particular joint is called ternary joint, and 4 links with a particular joint is called quaternary joint. For ternary joint, the equivalent binary joint is 2, and quaternary joint, the equivalent binary joint is 3. So in this picture, the link 1 and link 2 is connected at one particular joint. So here it forms a binary joint. Similarly, in the next picture, we are seeing link 1, link 2 and link 3 are connected at the same point. So we call it as a ternary joint. Similarly, when 4 links are connected to the point, we call it as a quaternary joint. Similarly, joint order can also be determined as using the equation number of L link minus 1. So in the first figure, the joint order is 1. In the second picture, the joint order is 2. So these are some of the terminologies of the joints. The lower pair is a joint with surface contact. A higher pair is a joint with point or line contact. A full joint has 1 degree of freedom. A half joint has 2 degrees of freedom. The full joints are lower pairs. The half joints are higher pairs which allow both rotation and translation. The form closed joint is the one in which the links are kept together by the form by its geometry. A force closed joint requires some external force to keep the links in contact. So these terminologies will be used in solving the problems. So coming to the chain, the kinematic chain is the combination of 4 or more kinematic pairs such that they have the relative motion between the is fully completely constrained. So in the first picture, you have 3 links connected together. That is called 3-bar linkage. In the 4-bar linkage, you have 4 links connected together, and in the 5-bar linkage, you have 5 links connected together. So coming to the simple chain, when the number of links in the chain is less than or equal to 4, we classify them as simple chain. And for the simple chain, the following equation should be satisfied. Link is equal to 2p minus 4 and joint is equal to 3 by 2 L minus 2. When this equation is satisfied, we call it as constrained kinematic chain. When left hand side is greater than right hand side, we call it as locked chain, and left hand side is lesser than right hand side, we call it as unconstrained chain. So using this equation, we can classify a chain as locked chain, constrained kinematic chain and unconstrained chain. When there is a compound chain, that is number of links greater than 4, we call the chain as compound chain. And when the compound chain is there, the following equation should be satisfied. So in this equation, higher pair is considered, J plus H by 2 equals 3 by 2 into L minus 2. Same here, then LHS equal to RHS, we call it as constrained kinematic chain, and when LHS is greater than RHS, we call it as locked chain, and when LHS is lesser than RHS, we call it as unconstrained chain. So these are the equations. When these equations, want to remember these equations to identify whether the chain is locked chain or kinematic chain or unconstrained chain. Here L represents number of links, P represents number of pairs, and J represents number of equivalent joints, and H represents number of higher pair. So coming to the problem, here we take 3 connected links, link 1, link 2 and link 3, and the joints are named in alphabets. So the number of links is 3 and number of pair is 3 and number of joint is 3. Since this linkages have less than 4 links, 2 equations should be satisfied. That is L is equal to 2p minus 4 and J is equal to 3 by 2 L minus 2. So in this problem, LHS is greater than RHS. So we classify this chain as locked chain or rigid frame or structure. So in this problem, we have all the fixed links taken as 1 and 2, 3, 4. So totally 4 links are there and 1 ternary joint is there. So here you have the one ternary joint. This is a ternary joint where all the 3 links are connected. So this ternary joint should be taken as 2 equivalent binary joints. So here 2, 3, 4 and 5. So number of joint in this problem is 5. No higher pairs are there. So H can be taken as 0. So applying this equation, 5 plus 0 is equal to 6 minus 2. So 5 is greater than 4. So this mechanism or this picture, we can classify this chain as a locked chain or structure. In this problem, 4 links are connected. So the 4 links are connected, we can tell there are 4 links, 4 joints and 4 pairs are there. So since it has less than or equal to 4 links, so 2 equations should be satisfied. L is equal to 2p minus 4 and J is equal to 3 by 2 of L minus 2. So here LHS is equal to RHS. So both equations are satisfied. So we call this type of 4-bar chain as constrained kinematic chain. And coming to the compound chain, here the number of link is 5 and number of pair is also 5. Number of joint is equal to 5. So for the compound chain, J plus H by 2 equals 3 by 2 L minus 2. This equation should satisfy. So on applying the values, you will be getting left hand side is lesser than right hand side. So we call this as unconstrained chain. This is another problem. We want to prove the slider crank mechanism shown in the figure is constrained kinematic chain and find the type of chain if one link is added to it. So this is a 4-bar inversion of the 4-bar thing. You have slider crank mechanism where you have 4 links, 4 joints and higher pair is 0. So joint in the case 1 and 2 links make one joint, 2 and 3 link make one joint and 3 and 4 makes one joint and 4 and 1 makes one sliding pair. The sliding pair can also be taken as a joint. So 4 joints and 4 links with no higher pairs. So apply in this equation 4 equal to 4. So left hand side equals RHS. So we are proving that slider crank chain is a constrained kinematic chain. Now adding one link to this chain will become number of link is 5 and number of joint is also 5 with higher pairs equal to 0. On equating, we'll be getting left hand side is lesser than right hand side. So we classify this chain as unconstrained kinematic chain. So from this problem, we can tell by adding one link to the slider crank mechanism, the constrained kinematic chain turns to unconstrained kinematic chain. This is another kind of problem. We want to prove that given mechanism shown in the figure is constrained kinematic chain. So looking into this problem, whenever you want to prove the mechanism as constrained kinematic chain, we should show that the left hand side is equal to RHS and see the number of links. So in this problem, the number of links is greater than 4. So only one equation should satisfy, that is j plus h by 2 equal to 3 by 2 L minus 2. So you want to find out number of joints, number of higher pairs and number of links. So in this problem, all the fixed links are taken as 1 and this is A, B, 2, 3, 4, 5, 6. 6 is a slider. So totally 6 links are there. And coming to the binary joint, A is a binary joint which connects 1 and 2 and B is a ternary joint which connects 2, 5 and 3. So the equivalent binary joint is 2 here. Similarly, C connects 3 and 4. So C is a binary joint. D is also a binary joint which connects 1 and 4. E is a binary joint which connects 5 and 6. And F is a slider pair, can be taken as a joint which connects 1 and 6. So here we have 5 binary joints and 1 ternary joint. So 5 plus 2 will give you total number of joint is 7. No higher pairs are there, so h is equal to 0. Applying this value in the equation j plus h by 2 equals 3 by 2 L minus 2, we get left hand side equals RHS. So we are proving the given mechanism is a constrained kinematic chain. Thank you.